Okay, Game Center number 2 is called the Loopster Game Center, the All Operations Edition. Now, I am assuming that you've already watched the first Loopster Game Center video, which was multiplication only. That's where I went through the logic of all the puzzles with the Sudoku puzzles and how you can use logic to solve these. If you haven't, you might want to go back and watch that. And I'm just going to assume that you're aware of how a Loopster puzzle is solved. In this new book, it's called the All Operations Edition, and the reason is because in this book, sometimes we're going to be doing addition only puzzles, we'll be doing subtraction only puzzles, we'll be doing division only puzzles. So there's lots of operations that are in here. Okay, again, a loopster puzzle always has its name in the bottom left hand corner. This is a loopster 1, 2, 3, 5. That means you need a 1, a 2, a 3, a 5 in every row and every column. But this one's addition only. That means that when you look at the loop band around it, you see the two circles. The answer is 8, but now it's a sum of 8, not a product. So the sum is 8, so that means two numbers add up to 8. These two add up to 3, add up to 7, 4, and so on. Okay, so let's give this one a shot. Let's grab a pen. Da-da. Here we go. What two numbers add up to 8? Well, again, looking here, the only two numbers are 5 and 3. The problem is we don't know if it's 5 with 3 or 3 and 5. When you don't know, you don't guess because that can cause all kinds of logic problems later. Here we go. We jump down to this one. These two add up to 7. Out of these combinations, the only thing you can add to make 7 are 5 and 2. But I can't have a 5 in my first column because I already have a 5 up here. So this has got to be the 2, and this has got to be the 5. By process of elimination, I've used up my 2, my 3, my 5, so this number has got to be the 1. 1 plus what equals 4? Well, obviously that's 3. I come to my 5. What adds up to be 5? The only two numbers here are 2 and 3, but I have a 3 in my bottom row already. So this has got to be my 2. This has got to be my 3. I used up my 1, my 3, my 2. This has got to be 5. 5 plus what is 6? 5 plus 1. Again, I'm going quickly because I'm assuming that you're familiar with the logic from the first video. We come up to the 4. What adds up to 4? Well, it's got to be 3 and 1. I already used a 1 in the last column, so this has got to be the 3 and the 1. Used up my 5, my 1, my 3, so this has got to be the 2. 2 plus what is 7? Got to be the 5. What adds up to 3? It's got to be 2 plus 1, but I already have a 2 in the top row, so this has got to be 1, and this has got to be 2. Now I'm back to the beginning with my 5 and 3. I didn't know which way they go, but I do now because I know I used up my 2, my 5, and my 1. This guy's got to be 3, and this has got to be 5. So this is a loopster that uses only addition. This puzzle is a loopster that uses only subtraction. Now, the main thing to remember for this, and this is something you'll have to emphasize with the kids, is that I did not make them, what is the word here? Space orientation related, which means what two numbers in here make 8? Well, obviously it's 10 and 2, right? 10 minus 2. I did not make the 10 always go on the top and the 2 on the bottom. Same thing when it's left to right. If it's a 9, it's not, it's obviously 10 and 1, but it doesn't go always 10 and 1. It could be 1 and 10. What it means is the loop says that the two circles, when they are, when you find the difference of them, the difference is 8. So in this one, it's obviously to get an 8, it's 10 and 2. But I don't know if it's 10, 2 or 2, 10 because either way, they're going to have a difference of 8. So let's put my 2 and my 10 here. Now, what has a difference of 9? Well, obviously, it's 10 and 1, but I can't have a 10 and I already have a 10 in my first column, so this can't be the 10. He's got to be the 1. He's got to be the 10. By process of elimination, in my first column, I have a 1, a 2, and a 10. So what didn't I use yet? A 5. So here's my 5. I have a number 5, and the difference is 3. So that means it can either be an 8 right here. Does that make sense to you, teachers? 8 and 5, the difference. But there's no 8 down here. So obviously, if it's 5, this has got to be 2. Difference of 3. Come to here. Let's have a difference of 5, 10 and 5. But I already have a 5 in my bottom row. So this has got to be the 10, the 5. Process of elimination, 5, 2, 10. It's got to be a 1. Got to be a 2, and so on. So subtraction doesn't matter about left to right or up and down. Same thing with division. Division here, loopster 1, 2, 8, 24. Division only. Same thing. What makes an 8? Well, the only thing here is 8 and 1, but it doesn't have to be 8 and 1. It could be 1 and 8. I don't know because what I'm saying is when you divide the two numbers in here, the quotient is 8. So here we go. I use up my 1 and my 8. Come down here. What can make 4? Up, up, up. 8 divided by 2 is the only thing, but I've already used up an 8 in this first column, so it can't be 8 and 2. It's got to be 2 and 8. By process of elimination, in my first column, I used up a 1, a 2, and 8, so this guy has got to be the 24. 24 to get 24, this has got to be 1. Come over here, what gives me a 2, 2 and 1, but I already used the 1 in the bottom row. This is the 2, this is a 1. Process of elimination, 1, 2, 24. This guy has to be an 8. What number combined with an 8 can give me a quotient of 3? Obviously 24. And you just keep trucking. Come up here, 1, 24, and so on. So the big things with this one, the subtraction, and this one, the division, is that I did not tie my hands and say that they had to go left to right or up and down. They can go either way. That's very important because some people would think that it's different. Now, it's called all operations. So some of them have combined operations. This one is a 4 by 4, but it's got, you can use addition or multiplication. There's other ones that say all operations. You can use all 4 operations, but this one is only the 2, addition and multiplication. When I look here at 7, can I multiply anything down here to make 7? No. There's nothing that multiplies to make 7. Is there anything that adds to make 7? Oh, that's not a great example, but you'll see why in a second. What adds to make 7? Well, it could be 2 and 5, or it could be 3 and 4. Now, when it can be more than one thing, personally, I don't even put in baby numbers. I just leave that blank for a second, and let's move on. Let's go down to here. What makes 9? Well, multiplying, I can only use 1, 3, so I can't multiply. So it's got to be an addition problem. Now, what down here adds up to be 9? Well, it can only be 4 and 5 or 5 and 4. I don't know which order they go in, so let's put a baby 4 and a baby 5. Now I come down here. What makes 5? Well, can't use multiplication because there's no 1. 5 times 1. But there is a 2 and a 3, and that can be added. So this is going to be my 2 and my 3. I don't know which way they go yet. But now I can start working. Now, how do I make a 10? Well, I can't add anything to get 10, right? Nope. But I can multiply, and it's 5 times 2. Now, looking in my bottom row, I already have a 2 over here. So this guy's got to be the 5, and this guy's got to be 2. Now, watch. Here's my 2, my 3, my 5. In my bottom row, I got a 2, a 3, and a 5. So I don't even have to do any thinking. Boom, it's got to be 4. How do I make a 4 turn into a 7? Well, not by multiplication, obviously. So it's going to have to be addition. 4 plus what is 7? Got to be 3. Come up here, how do I make a 6? Well, there's a couple ways. It could be 2 times 3. It can be 2 plus 4. But look, can't be, I can't use my 3 or my 4 here. So it could be like 2 with 3 here or 2 with 4 here. Since there's a couple choices, I personally just leave it blank. Because when you come up here, look, 20, there's only one way that guy can go. It's got to be 4 and 5, and I already have a 4 in my last column. So he's got to be 5. He's got to be 4. Now I can come back here and go, what's missing in my last? I got a 3, a 4, a 5. Got to be 2. What's missing in this one? Well, 5, 2, 4. I'm missing a 3. Oh, it was the multiplication problem. Okay. Now come back here. You just keep going around the puzzle. I'll go quickly just so you can see it. 12. What could that be? 3 times 4. Anything else? No. So it's got to be 3 times 4, which allows me to come down here. See, now that I know that this guy's a 4, he can't be a 4. So he's got to be the 5. She's got to be the 4, 3, 4, 5. This one's got to be the 2. If that's the 2, we already knew this was a 3. Come up here, 2, 3, 4. This has got to be a 5. And 5, 4, 3. This has got to be a 2. Hey, what operation was this? Yeah, it's addition. Okay, it wasn't multiplication. And this is the all operation book. So moving right along, here's one that has all 4 operations. You can add, subtract, multiply, or divide. These are obviously more challenging. And what else do I have? This book, just like the last book, let me jump back here. This is not the appropriate one, but I'll show you. At the end of the binder, there is a answer key, and the answer key is done in sections. It tells you the name of the puzzle right here, and then it gives you the 4 by 4 answers or the 5 by 5 answers, whatever it is. So this is video number 2. It's the Loopster Game Center All Operations Edition.